LLMs are brilliant, but they are limited by their training data, frozen in time at the moment they were created. To solve this, we use RAG, Retrieval-Augmented Generation. Without a connection to the outside world, a model can't answer questions about recent events or access your private internal documents. RAG bridges this knowledge gap. The RAG pipeline works in three main stages. First, it retrieves relevant data, then it augments the user's prompt, and finally, the model generates a grounded response. It starts with your knowledge base. This could be anything from a folder of research papers to a massive enterprise database containing real-time information. These documents are first broken into smaller chunks and converted into numerical vectors through an embedding model, turning raw text into the geometry of meaning we explored before. These vectors are stored in a specialized vector database, which allows the system to search for information based on semantic similarity rather than just keywords. When a user asks a question, that query is also converted into a vector, serving as a probe into the massive, high-dimensional knowledge space. The system performs a semantic search, retrieving the most relevant chunks of information that match the intent and context of the user's query. Next is augmentation. The retrieved chunks are stuffed into the prompt along with the user's question, giving the LLM the exact context it needs to answer correctly. Finally, the model generates the response. Because it has the source text in its context window, its answer is grounded in fact rather than just statistical probability. This significantly reduces hallucinations, the tendency for models to make things up when they don't have the necessary information in their weights. RAG also enables source attribution. The model can cite its sources, allowing users to verify the information and trace the reasoning back to the original documents. Because retrieval happens at inference time, you can update the knowledge base without retraining the model, allowing the AI to have up-to-the-minute intelligence. Many production systems use hybrid search, combining traditional keyword matching with modern vector retrieval to handle both specific terminology and abstract concepts. To further improve accuracy, a re-ranking step is often added, where a smaller, precise model evaluates the retrieved chunks to ensure only the most useful context is used. While models now have massive context windows, RAG remains essential for cost efficiency and for handling petabytes of data that even the largest windows can't hold. For developers, RAG offers a way to maintain data privacy, ensuring sensitive information is only retrieved when authorized, without it ever being baked into the model's weights. We are now moving toward agentic RAG, where the model can autonomously decide which tools to use and which information to retrieve to solve complex, multi-step problems. In summary, RAG turns a static LLM into a dynamic, knowledgeable expert by augmenting its generative power with a precise retrieval engine. For any AI developer, mastering the RAG pipeline is the bridge to building truly useful, reliable, and production-ready local AI applications. RAG reminds us that intelligence isn't just about what you know, it's about knowing where to find the answers. Our exploration of digital intelligence is just getting started. Join us in the next episode as we dive into mixture of experts and the power of modularity. Follow for more.